All right, welcome. Today, we're diving straight into the heart of every single Kubernetes node to really understand its most important agent, the kubelet. Let's get right into it. So think about a Kubernetes cluster for a second. You've got the control plane, right? It's up there making all the big decisions, sending out commands. But who's actually on the ground rolling up their sleeves and getting things done? Who is it that's really running your applications? Well, that's the exact question we're going to answer today. To really wrap our heads around this, we're going to use a simple analogy that makes everything click. Just picture your entire cluster as this huge, high-tech apartment building. Trust me, this mental model is going to make it all make sense. Okay, so in our apartment building, you've really only got two key players. First, you've got the management office. It's kind of floating up in the sky, giving all the orders, but it never, gets its hands dirty. That's your Kubernetes control plane. And then in every single apartment, you have a resident tenant. This tenant is the one who's actually on site, gets the orders, and does all the real work. And that hardworking tenant, that's the kubelet. So to put it a bit more formally, the kubelet is the main Kubernetes agent, and it lives on every single node in your cluster. And here is the most important part. It's the only component that's actually talking to the container runtime, like Docker or Containerd, to start, stop, and keep an eye on your applications. And you can see right here how perfectly this analogy lines up with reality. The tenant, that's the kubelet. The work orders from management, those are just pod specifications. Starting the washing machine in the apartment, that's the kubelet running a container. And when the tenant calls maintenance about a broken AC, that's the kubelet telling the API server that a pod has crashed. It's a pretty spot-on comparison, right? Okay, so now we know who the kubelet is. But what does it actually do all day? Well, its entire job can really be broken down into 5 core responsibilities. So let's do this. Let's follow a kubelet through a typical day. Once you understand these tasks, you'll see exactly how your applications come to life, and more importantly, stay healthy inside the cluster. Job number 1, and this is what it's doing pretty much constantly, is communication. The kubelet is always checking in with the API server, our management office, and it's asking one simple question over and over. Hey, you got any work for me? It's just scanning for any new pods that have been assigned specifically to its node. So once the API server says, yep, here is a new pod for you, the kubelet gets to its most important job. It reads that pod spec, it goes and pulls the container images it means, it sets up all the networking and storage, and then it turns to the container runtime and says, all right, go ahead and start this container. And boom, that's the magic moment your application is actually up and running. But its job is far from over. The kubelet is also like a super vigilant health monitor. It uses liveness probes to just ask, hey, are you still alive in there? And readiness probes to ask, are you actually ready to take on some traffic? Now, if a liveness probe fails, the kubelet plays doctor and just restarts that unhealthy container. And if a readiness probe fails, it basically tells the rest of Kubernetes, hold on, don't send any users this way until this pod gets its act together. And while it's juggling all of this, the kubelet is constantly phoning home to management. Every 10 seconds or so, it sends a little heartbeat to the API server. This message basically says, hey, I'm still here, my node is doing fine, and here's the latest status of all my pods and how much CPU and memory I have left. And that heartbeat, it's absolutely critical. If the API server stops hearing from the kubelet, it just assumes the whole node has gone down and marks it as not ready. Now, for the kubelet's 5th job, and this one is pretty cool, it has this kind of superpower. It can run what are called static pods right from YAML files stored on the node itself. This means it can start super important applications even if the entire control plane is offline. And here's the kicker. This is exactly how the control plane itself gets started. The kubelet on the master node literally brings the entire cluster to life. Okay, enough theory, let's make this real. We're going to look at a practical example to see how all these pieces come together when you, the user, just run a single, simple command. Okay, so let's walk through it. It starts with you. You're on your laptop and you type kubectl apply, sending your app's blueprint up to the API server. The control plane saves this plan and assigns the pod to one of your worker nodes. Just moments later, the kubelet on that specific node sees the new assignment. It immediately springs into action. It pulls the image, starts the container, and then reports back to the API server, hey, job done. The pod is up and running. It's a beautifully simple and effective workflow. Now, the kubelet isn't doing all of this heavy lifting alone. It's got a few special tools in its belt, some interfaces and internal parts that help it do its job really well. Let's take a quick look at what's in its toolkit.
First up, we've got the CRI, which stands for the Container Runtime Interface. The best way to think about this is as a universal translator. It's a standard that lets the kubelet give commands like start this container or stop that container without needing to know the nitty-gritty details of whether it's talking to containerd or Docker or something else entirely. It just standardizes the whole conversation.
Next in the toolkit is KubeAdvisor. And this is actually built right into the kubelet itself. This is the kubelet's own personal resource monitor. It's the part that's constantly gathering all that data on how much CPU, memory, and disk space every single container is using. This is the information that it packs up and sends back to the control plane in those status reports. And finally, there's a thing called PLEG, the Pod Lifecycle Events Generator. This is basically the kubelet's nervous system. It's this internal engine that's constantly checking on the containers and can instantly detect if something changes. So if a container just dies unexpectedly, PLEG is what senses it, and that allows the kubelet to react in a split second to go and restart it. You know, if there's just one thing you remember from all of this, let it be this simple idea. Everything else in Kubernetes, the scheduler, the controllers, the API server, they're all just planning and talking. The kubelet is the one who actually does the real work on the node.
And this brings us to one last really important thought to leave you with. If the control plane is the brain of your Kubernetes cluster, and the kubelet is the hands, what happens to the whole system when those hands suddenly stop working? It really just highlights how unbelievably critical this one little agent is to keeping everything you run healthy and online.